So we're looking at rapid application development here. Rapid application development, as the name suggests, is characterised by a very quick development cycle. And whilst we have seen a structured development involving the requirements, design, whatever, just doesn't do that. What we're looking at instead is less formal structure and more negotiation, discussion, build. Negotiation, discussion, build. And the graphics there are talking about that lack of formal stages, the use of existing subroutines or routines. Here we have a Lego Mindstorms application, and it's dragging in each of the code blocks as a preordained or pre-developed routine, which will make your development a lot faster. You could also look at this Scratch. Again, say that again? It's old Scratch? Well, it's still Scratch. Again, you're looking at the simple blocks to build your application, so you can build far more quickly rather than having to code every individual line. Another key feature of rapid development, and this also is a crossover with end user development, is the use of pre-existing software such as spreadsheets or databases to build your application. Now, this is a genuine piece of software from NESA called the Education Calculator. The way this works is that in the left-hand column, or in the columns that are surrounded by the red, you can put a bunch of values, percentages, for tasks that you have given. And what it's going to do is test out the value of that task, whether it's a good assessment task or not. And if you have all 6 sheets with data in them, you'll see how each value works and how each set of range of marks works. So in the very right-hand column, all classes average total, you'll see the black line is the range of marks from highest to lowest. The first pink square is, the first black line with the white background is the first 25% of students' results. The next pink square is the second 25% of results. The dot there is the mean or average value. The third 25%, so the third quartile, and the tail. And when you're looking at these results, you're seeing whether or not there's value in the task. So if you look at that right-hand side, that task actually looks like a good task because it's separating the better students from the less able students. It's giving a good range of values. But this software was developed by NESA for us to use, and it was designed as a rapid application, work its way through. I think what happens here now, this is actually a really nice graphic to explain how rapid works. You're starting in the middle and you are having a little bit of a think, design, demonstrate. In the demonstration stage, you are talking to your end users. Show them what you want. Show them what they want and see if you can get some feedback. Continue developing, refining, discussing, testing, and finally implement. Another way to look in, this again, a very similar way. You see also there's always these feedback cycles. So check in, see if it works, get some feedback, build, check in, feedback, build, feedback, automated acceptance, user acceptance testing, and final approval for release. So you'll see there's none of that structured design, plan, build, test. It's a lot of negotiation, discussion. You'll see this also crosses over quite a bit with prototyping as well. Nice little summary here. Deciding your requirements, building a prototype, which you'll see does cross over with prototyping. Get some evaluation and feedback from the customer, refine, review, build, test, implement.